Welcome to my channel Glory with Mathematics. Please subscribe, like and share. Dear students, let us discuss the next part of the chapter whole numbers. Here in this section we shall discuss about two properties of whole numbers. They are closure property and commutative properties. So let us discuss properties of whole numbers. First property is closure property. So closure property under addition. The sum of any two whole numbers is always a whole number. That means the collection of whole numbers is closed under addition. So you can take any whole numbers and then add these whole numbers. The sum will be also a whole number. So 7 plus 8, 7 is a whole number, 8 is a whole number. Their sum is 15 is also a whole number. 5 plus 5 is equal to 10. 5 is a whole number and their sum 10 is also a whole number. Then 6 plus 15. 6 is a whole number, 15 is a whole number. Their sum 21 is also a whole number. Then 0 plus 18. 0 is a whole number, 18 is a whole number and their sum is 18. That is also a whole number. Then 2 plus 20. 2 is a whole number, 20 is a whole number. So their sum 22 is also a whole number. This property is known as the closure property under addition of whole numbers. So this concludes that if A is a whole number and B is a whole number, then A plus B is also a whole number. Then come to closure property under multiplication. The multiplication of two whole numbers is also found to be a whole number again. So you take examples 7 into 8. 7 is a whole number, 8 is a whole number and their product 56 is also a whole number. 5 into 5 that is 25. 5 is a whole number and the product of 5 and 5 that is 25 is also a whole number. 0 into 15. 0 is a whole number, 15 is a whole number and their product 0 is also a whole number. 8 into 10. 8 is a whole number, 10 is a whole number and their product is 80. That is also a whole number. Then 12 into 7 is equal to 84. 12 is a whole number, 7 is a whole number. Their product 84 is also a whole number. We say that the system of whole numbers is closed under multiplication. That means if A is a whole number and B is a whole number, then A into B is also a whole number. Hence, whole numbers are closed under addition and multiplication. Then look at this table. 6 minus 2 is equal to 4. Here 6 is a whole number, 2 is a whole number. Their difference is 4. 4 is a whole number. Then 7 minus 8. 7 is a whole number, 8 is a whole number. So 7 minus 8 is not a whole number. Then 5 minus 4 that is equal to 1. 1 is a whole number. Then 3 minus 9 is not a whole number. Then 12 minus 15 that is also not a whole number. So here we observe that whole numbers are not closed under subtraction. If A is a whole number, then B is a whole number, then A minus B may be a whole number or may not be a whole number. So like this in division also, 8 divided by 4 is equal to 2. 2 is a whole number. So here we divide two whole numbers and the quotient is a whole number. So 5 divided by 7. 5 and 7 both are whole numbers, but 5 by 7 is not a whole number. Then 12 divided by 3 is equal to 4. 4 is a whole number. But 6 divided by 5, that is equal to 6 by 5. It is not a whole number. So it concludes that whole numbers are not closed under division. So division by a number. Division by a number means subtracting that number repeatedly. So let us find the value of the division 8 divided by 2. Now subtract 2 again and again from 8. So observe after how many moves did we reach 0? It is 4. So look at the steps of subtraction here. 8 minus 2 is equal to 6. 6 minus 2 is equal to 4. 4 minus 2 is equal to 2. Again 2 minus 2 is equal to 0. So we got 0 after 4 steps. So here we can write 8 divided by 2 is equal to 4. Let us now try 2 divided by 0. Here in this case, in every move, we get 2 again and again. If we subtract 0 from 2, in each step, we will get 2. So, we never get 0. So, 2 divided by 0 is not defined. Let us now try 7 divided by 0. So, by the rule of divisibility, by the principle of repeated subtraction, we have to subtract 0 from 7 repeatedly till we get 0. But here in this case, in every move, we get 7 again and again. Will this ever stop? No. So, look at these subtractions. 7 minus 0, we got 7. Then 7 minus 0, then 7. Then minus 0, we get 7. So, this step will never end and we will never get a 0. So, that means 7 divided by 0 is not defined. So, division of a whole number by 0 is not defined. You have to remember this. Division of a whole number by 0 is not defined. Then commutative law. Commutativity of addition. So, you can take 3 plus 5 is equal to 8. And 5 plus 3 is also equal to 8. So, we can prove this in number line also. So, 3 plus 5, if we add 5 with 3, then we will get 8. Or if we add 3 with 5, then also we will get 8. So, you can add two whole numbers in any order. We say that addition is commutative for whole numbers. This property is known as commutativity for addition. If A and B are whole numbers, then A plus B is equal to B plus A. This is the commutativity of addition in case of whole numbers. Then commutativity of multiplication. So we know 2 into 6 is equal to 12 and 6 into 2 is also equal to 12. You can multiply two whole numbers in any order. We say that multiplication is commutative for whole numbers. This property is known as commutativity for multiplication. If A and B are any whole numbers, then A into B is equal to B into A. So commutative property for addition and multiplication, you can add in any order. A plus B is equal to B plus A. For example, 3 plus 5 is equal to 5 plus 3. And under multiplication, you can multiply two whole numbers in any order. That means A into B is equal to B into A. For example, 2 into 6 is equal to 6 into 2. So subtraction is not commutative for whole numbers. That means if A and B are any whole numbers, then A minus B is not equal to B minus A. Division is also not commutative for whole numbers. If A and B are any whole numbers, then A divided by B is not equal to B divided by A. Thank you.